So hello and welcome to this, which is the second episode of our lecture series on Python. In this episode we're going to introduce you to some of the basic elements of the language, and don't forget, at any point you can pause the video and try out the code segments in the window below. Python's what we call a simple interpreted language. And the word interpreted means that unlike programs in C, Java, Fortran and C#, Python programs don't have to be compiled before they can be run. Commands are executed immediately. To run Python interactively from a command shell, just type Python. And this brings up a prompt, which is usually 3 greater than signs. You'll see this shown in the window below. You can have Python do some simple arithmetic, or manipulate strings of text just by typing in some commands. More often though, you put some commands in a file and have Python execute that. For example, on Unix systems or Linux systems you can use a simple editor like Pico to put the same commands we just ran in a file called verysimple.py and then have Python run that. A third choice though that combines the best features of the two is to use an integrated development environment, or an IDE. Now, we'd recommend something like Wing 101, which is the free student version of Wing, but there are a number of others available. The IDE gives you an editor that's customized for displaying Python source code. And it gives you an interactive shell for trying things out. We'll explore some of the other tools that IDEs provide later on in this course. But back to Python itself. Like other languages, it allows you to create variables. These are just names for values. But unlike compiled languages, Python variables are created by use. There's no need to declare them explicitly. For example, assigning the string Pluto to the variable planet automatically creates that variable. And we can print out its value to make sure it's right. Internally, Python stores a table of all the variables that we've created so far and keeps track of the values that they refer to. So if we assign another string to the variable moon, Python adds an entry to the table for moon, allocates some memory to store the string, and then makes the variable point to that string. We can also assign variables to variables using a statement like p equals planet. This creates a new variable as before, but this time the variable points to the same value that planet was pointing to. And sure enough, if we print p, Python displays the string Pluto. A variable then is just a name. And unlike variables in some other languages, Python's variables don't have specific data types. For example, we can assign a string Pluto to planet, creating the table entry shown here, and then immediately assign the integer 9 to the same variable. Now in a language like Java, this would be an error because strings and integers are different data types, but Python's quite happy to do this. And one other important feature of Python is that values are garbage collected. And this means that if nothing refers to a piece of data any longer, Python recycles its memory. For example, once we assign 9 to planet, nothing's pointing at Pluto any longer, so Python's free to reclaim that memory and use it to store other information. And Python's really very relaxed about the type of data that's assigned to variables, but it does insist that variables have values before they're used. So for example, let's assign the string Sedna to planet, and then try to print the value of the variable plant. Notice we've missed the E out. Python immediately displays an error message because we haven't defined a value for anything called plant, but it doesn't fill in some sort of default value for undefined variables such as 0 or an empty string, because doing so can mask errors that result from simple typing mistakes. And also, whilst we're here, notice that Python's commenting convention. Anything from the hash character to the end of the line is ignored, which allows programmers to add explanations or warnings to their programs. In contrast with variables, values in Python do have types. For example, suppose we try to multiply a string by a number. Python's okay with this. It knows what star means when applied to a string and an integer. But if we try to add a string and a number, we get an error message because Python doesn't know what the plus symbol means when we apply it to these types. In this case, you probably think that 2, 3 would be a sensible answer. But then what should be the result of adding the string 2 to the string 3? Should it be the string 23, the integer 5, or the string 5? And in programming languages, experience teaches us that doing too much is just as bad as doing too little. If we really do want to add the string 2 to the integer 3, perhaps we can use some built-in functions to convert one or the other first. Things like int. This function takes a string of digits and produces the corresponding number, whilst the function str turns a number, or almost anything else, into text. And speaking of numbers, Python provides several types. We've got integers, which on most machines are stored in 32 bits. Python also provides floating point numbers, which are usually stored in 64 bits, and complex numbers, which are written using J for the imaginary part. These are stored in a pair of 64-bit numbers. So if x is a complex number, then x.real and x.imag are going to be its real and imaginary parts. And of course, Python provides the usual arithmetic operations on numbers. We've got plus for addition, which we can also use to concatenate strings. We've got minus for subtraction. We've got the star for multiplication. We can use this on strings as well. We've got the slash for division, which produces an integer throwing away a fractional part if both of its arguments are integers. We use the double star for exponents and the percent sign for integer remainder. And like all the other languages in the C tradition, Python lets us use in-place forms of binary operators to make our programs more readable. So let's take this example. Suppose we've assigned 500 to the variable years. So if we write years plus equals 1, Python adds 1 to the variable years. It's exactly the same as writing years equals years plus 1, but it's shorter and easier to read, particularly if the expressions involved are long or complicated. So, sure enough, we've incremented years by 1. Other binary operators have in-place equivalents as well. So here, for example, percent equals replaces the value in years with the old value modulo 10. And again, this is the same as years equals years percent 10. And the answer is what we'd expect. Arithmetic operators turn numbers into numbers, but comparison turns numbers or strings into the values true or false. Simple ones like less than are written just as we'd expect. But Python uses exclamation mark equals or bang equals to mean not equal, and a double equal sign to test for equality. But remember, a single equal sign means assignment, the double equal sign means equality. Of course, partial inequalities like greater than or equal to can be used as well. And unlike most programming languages, Python allows inequalities to be chained together just as we do in maths. And we can even change the sense of the comparison halfway through, but please don't, it's very hard to read. And please don't try to do any kind of comparison on complex numbers other than equality and inequality. It doesn't work in Python any more than it works in maths. So again, before we move on, please take a look at the questions below.